Today, we're talking about setting control limits, and next steps is the topic. So we'll talk about control limits for a good amount of it, and then we'll talk about how we translate the use of control limits into actionable value, or what would be the next steps to using control limits appropriately. So let's dive right in. So what is a control limit? Control limits are a generic term, but they're traditionally in the process improvement space taught in more of the Six Sigma method. And the easiest way, this definition I wanted to highlight, is they're the horizontal lines in a control chart that delineate the upper and lower limits of the acceptable range of results for a process. So I know when we talk about control limits, the definition of they are horizontal line in a control chart can feel dry, but I wanted to fix this visual in your mind. But in reality, a control limit is just a threshold, and we'll talk more about that. It's a threshold that allows a monitoring agent to know that the process is getting out of control. So you set a control limit, which defines what within control is, and any data that starts to indicate that a process is behaving out of control is beyond that control limit. And that's what you're talking about here on the slide, but also you want to know there's typically an upper control limit and a lower control limit. So if you see UCL and LCL, that's what those refer to. And in a given set of data, there's always going to be bounds. You could say that the chart starts at 0, and that means the upper control limit is just going to be the only control limit that matters because the values can't be negative. But in most processes, you could measure a upper and a lower control, and within control would be anything within that range of values, and anything outside of that would be out of control. So what does it mean to be out of control? Well, in the traditional Six Sigma sense, out of control is really referring to values that are starting to show unacceptable levels of variation. In Six Sigma, when we talk about variation equates to waste in processes. So when you have a standard process, and especially back when it was more manufacturing, and I'll talk about how this applies to digital services just in a moment. But when you're in a manufacturing environment, you need everything to be very precise. All the outcomes of a process need to be within very standard and precise parameters. So if you start to have data that's popping up in a process that's cycling over and over again, that's starting to get away from the expected mean or the expected values, what you're seeing there is unexpected or uncontrolled variation in the output values. And it's that variation that generally we care about because it leads to defects. But it also, in most processes, variation, uncontrolled variation particularly, is normally what's leading to all sorts of waste in the organization. Because in manufacturing, defects are the primary indicator, because you don't want something coming off the line that's just broken or not fit for purpose. But in digital services, variation can cause all sorts of waste. And there's actually an argument that control limits in service organizations, even though we have more tolerance for defect reduction in services, like if you have an error in your data entry, or it's a little late to the customer, those kind of defects in process, and I'm using air quotes, they can be there's a little more tolerance in services, especially in the digital age, but it doesn't mean that if you're not measuring it, you can't see when variation is starting to be an indicator that something is going wrong and needs your attention. But in general, like I said, the whole idea is you want a process behaving a certain way, and once you know how it's supposed to be behaving, you should be able to set a control limit. So if you go down, if you haven't already read the slide, if you go down to setting control limits, it has to necessarily define a context around a process. And number one would be how that process should be behaving. Because if you're going to say this is uncontrolled variation or this is unacceptable performance, you have to, one, know how a process should behave. And in the digital world, that can actually be quite challenging because we don't know. It's not like a factory line like it used to be in manufacturing, where you could just look at it and say, I know how these machines should be behaving and it should be the same way every time. Knowing how a process should behave is, in the digital services world, which I'm sure most of you are in, it's a little bit more of an exercise. So don't go into this thinking, okay, we just need to know what the control limits are. You have to know what the process should be doing first to set control limits. And then the second thing is, how are you going to apply measures to that behavior to indicate that the process is behaving? We'll talk about measures in a moment too, because they're critical for control limits be conceived. It doesn't mean a control limit, the UCL and the LCL, is just going to be these lines on a chart. In every context, depending on the process, it's going to be different. So it matches that process. So once you know how it behaves, then it would give you an idea of what you need to measure to know that it's behaving. And then the third point, sort of back to the control limit conversation we've been having, which is once you know what should be happening and how it should be measured, then you create the thresholds so that you can determine when the behavior is becoming normal. And really, the whole point of control limits is knowing when do I need to give the process attention or additional oversight so that I can avoid the negative outcomes that the process is starting to exhibit if the values keep getting out of control. Because control limits, as part of this narrative, they're created for monitoring. If you think about what are we doing with the control limits, if you set a control limit and you don't monitor it over time, or you don't monitor the process data being created, then really there's no point in creating a control limit. So we're starting to have that conversation about what are the next steps. I go through all this work to create right control limits and understand my process behavior, and then I've got to think about how I use that into some sort of monitoring process. And generally what you're monitoring at a high level are results of a process, just the general measures that the process is creating in its operation, or the operating metrics, which are just compound measures essentially. So how are my measures looking over time? Those are the things where you can start measuring ROI, efficiency, effectiveness, quality, things like that. So we're monitoring to check against, you do monitoring to check progress against plans, and that's for decision making. And control limits are all part of this conversation. Control limit is just, you can think about it as a refined tool for monitoring in a way. Because you can monitor a process and use your instincts as to when the process is going sideways or starting to produce negative outcomes. But the whole idea about control limits is that you've already done the work. You've done a more methodical way of creating these upper and lower control limits. So you don't really need to use somebody's intuition. And the monitoring process actually becomes more standard. So again, to kind of just summarize that thought, setting control limits is you need to know what the target process is. And this is part of knowing how it should behave. But the first step is, what is it? What are you trying to actually control? So that's an easy kind of narrative point, which is if I have the need to set a control limit in your organization, the first question you need to answer is what is the scope of what needs to be controlled? And then you talk about what are the process objectives? What does in control look like? So if you're going to define a control limit, remember the narrative we're building here, because it's easy to get lost in the technicality of it, especially if you're reading the Six Sigma manuals. But really what you want to answer in a conversation with somebody is, I'm creating control limits because I need to keep something in control. So we just talked about you need to first set what needs to be in control, and then what does in control look like? What does that mean? And again, defining what is the process meant to do, and then the measure part is how can it be quantified? And the reason I'm spending a lot more time here is because if you're thinking about digital services, how it can be quantified is often going to be how is people's behavior going to be quantified? How are dimensions of the output of a service or something intangible going to be quantified? If you can't get your head around measuring the intangibles like I'm talking about, then it's going to be really hard to set control limits or controls at all, really. So let's think deeper about how measuring starts with the process pieces that I'm talking about. So again, outside of this is going to be a generic conversation about what universal measures do you need to think about how to measure a process. And there's really a lot of them, and there's infinite metrics that you can make out of, a very universal set of measures. But having an accurate as-is process map or having some sort of process documentation is going to be the start. What is the process? Because once you can understand it from that perspective, then the idea of setting control limits and things like that becomes much more easy. So if you look at the slide with me, I've got a basic swim lane diagram flow where in red you see, okay, what is happening? Where's the activity happening? The systems or the physical locations, who's doing it, and when is it happening in sequence? And then you can also have a lot of, it's just the 5 W's essentially of a good process story. When you got that down, what it actually implies visually is all the measures you would need to think about. What is the cost of resources? What is the cost of machines or technology being used? Is there cost of actual raw materials? Those are kind of all your costs universally that a process can consume. And then there's cycle time, which is the time it takes to do an activity, a cycle of an activity. And then there's wait time, which is the time between activities. And then you have lead time, which is the entire, all the cycle time plus wait time combined for an entire set of scope that you want to look at from a process. And then you have the cost of poor quality, which is the cost of defects and some other things. But I just gave you essentially all the universal measures. This is, if not more like 99-1, it's definitely your 80-20. So if you're in this presentation because you have to start setting control limits are going to usually start with this diagram right here, which is what is the process, and then what out of these universal measures are relevant to the process's functioning or its objectives or its value creation. And once you kind of start here, you're going to be on a good footing to be able to discuss what it is. And these measures are just, if you're thinking, oh, I've never seen anything like this, it's a bit overwhelming. It's just your cost, speed, and quality, or your cheaper, faster, better measures. These are the universal measures of cost and process dimension. And essentially what you're always looking at, what is actually being consumed as the process cycles? That's the cost category. What's the actual speed that process needs to be working or cycling at to meet customer objectives? And then what is it producing? So you can see in this quality one, I added a few more. You can talk about customer lifetime value. That's a better one for service organizations than, let's say defects per unit, which would be typically more manufacturing. Because defects per unit, just so everyone knows, like when you're in a service organization, let's say you're doing financial services, you're in insurance, something like that. Defects per unit, I've seen them as high as you can have like 85 defects per unit that goes out. If you're talking about the creation of a policy or a loan, you could have hundreds of defects. When you actually audit the transactions, defects per unit doesn't even make any sense because there's so much tolerance for the process actually being completed with errors and it's still having the right result. It's no longer a measure for services. So again, picking the right measures and kind of thinking about them the right way is going to be critical to being able to set control limits and manage them. So we talk about measures. I also just want to take a moment to talk through metrics because I know I mentioned it. When you start to get those universal measures, metrics is just a combination of them, usually a fraction or a division. And I'm sure everyone has been used to using business metrics, but I like to call it out because sometimes measures and metrics are kind of muddled and they can be used interchangeably as terms. But when you're using control, when you're talking about control limits, you need to have some sort of technical precision about, am I taking raw measures? Am I measuring, am I taking a metric for my control limit? Because this is going to impact how it's monitored over time. But you can see here essentially that some of these metrics can get quite complicated. I picked some complicated results here where if you're talking about the ROI, the return of a process, that could be the entire process budget, which could be a combination of lots of those cost figures I just showed you for measures over the measured value of outputs. You can have efficiency, which is the ROI over time. You can have effectiveness, which is the quality of outputs over the cost. There's a lot of different things you can do with metrics, but again, it's all going to be derived from these same process measures. You can't really measure a process in the physical world, even if it's a digital process, much differently than those. And just a quick note here on control limits and process metrics in general. On the right-hand side, I want to articulate to everyone that an efficient process does not always produce a good product. So remember, you can't just pick a hodgepodge of measures and expect to get anything out of it. You have to pick the ones that associate with what the product is trying to be or the process is trying to do. So costs and these things, like when you're talking about different processes, can be quite complicated. So don't go into it thinking I'm just going to select a bunch of things and it's going to give me the right measuring result. Sometimes you can measure the wrong thing and influence the wrong behavior. So again, what are the right metrics? Because those are the ones that you need to use for control limits. And this is very a repeat, but kind of in the short session, I want to make sure we're drilling in the right thing here, which is what is the process? You've got to do the as-is process work first. And then what are the objectives for value creation? And what are the metrics that associate with value creation? So generally for control limits, well, for every process type of monitoring, you're going to want to make sure you're tying it with the value creation of the process. And that could be, again, obscured. But when you're doing it, if I've got the right measures and the right metrics in place that measure value creation of the process, then it's really just identifying for whatever process it is, what is the acceptable tolerance for the process to go in terms of errors or things going wrong or having variation that slows down or adds cost, so that the value creation of the process is no longer positive, is the way I would say it. So let me talk through a more tangible example of that. Let's say you're making t-shirts, and it normally, you sell the t-shirt for $80. Well, let's make it more real. You sell the t-shirt for $20 and it costs about $18 to make. So you're running on a $2 margin. What will happen is, if you're setting control limits, anything that would make the ROI negative for the company. So let's say costs go above 20, then every t-shirt you make, you sell it for 20, but it costs you $21+ to make it. So value creation in the profit opportunity sense has just gone negative. So when you're measuring the control limits, like you're showing here, you're setting a chart that says, I know that for these metrics or a set of measures, if they start going over certain value thresholds, I'm going to start incurring more cost, which at some point you could say is going to start pushing me toward that $20 threshold, where at which point value creation for each t-shirt I make is going to be negative for the company. And that would be like a simple way to think about control limits. There's a point here in the bottom where a lot of Six Sigma is about, okay, standard of deviations from the mean. And I just pointed it out because that can be very arbitrary. A lot of times in Six Sigma, if you're 2 or 3 sigma away from the mean, it's really talking about the process is starting to go off rails, but that doesn't even necessarily associate with negative value creation. In a lot of simpler settings where you don't have to be so technical or mathematical about it, it's really the question I just posed, which is what would be positive value creation and when does it turn to negative value creation in a process? And if you can identify that, then you want to set control limits that are starting to show you when the process is veering off towards negative value creation or unacceptable levels of cost. That's a more anecdotal way to think about it. And especially depending on the kind of process you're trying to control, that should help you conceptualize what you're attempting to do. So that was a lot of just discussion about control limits and measures and metrics and monitoring, because they're all related in the same type of space. So when you get your head around that stuff, and I know this is very short for what can be a very technical topic, but the next step is typically project work. So the reason you monitor is because when something is going wrong, then you would typically want to create a project to address it. So when we talk about control limits and next steps is projects. So when a control limit is breached, it really is the beginning, if you've set it up correctly, of articulating your problem statement for a project, if you think about it that way. So my control limits are going off the rails, and the process is out of control. Also meaning, if you did it right, that the process may be starting to create negative value for the organization. And that is always something that is grounds to address. So if you can see my cursor, or if you can't, an operating process is just operating at positive ROI. And then you see, like, I kind of wrote this little thing as, think about it as a pipe breaking, or energy starts leaking out of the process, or a control limit is violated. But essentially something here is meaning there's energy being created to fix this operation, because otherwise it's going to start creating negative outcomes for the organization. And when that happens, then a project sponsor is the first person should pick it up, and then it should be chartered, and then a project manager should pick it up, and then you assign all the tasks to a project team, and then you do the project work to try to gum it back up, or to basically fix, repair, evolve, heal, whatever word makes the most sense to you, the operating process. And a lot of times these problems, if in organizations when they're not being monitored, people just know there's problems because they're seeing money go the wrong way in organizations, and people try to go through this cycle and start a project. In mature organizations, you'll see the problems forming ahead of time with control limits and control limit violations. So if I have a control limit in place and I start to see it being violated, then I already know that I've got the fodder or the energy or the base material to start a project to attempt to fix it. And that's how you rally people's efforts in a typical project cycle to tackle it. So when you're translating that monitoring into action and you're setting up control limits, you want to also just be sensitive to the fact that these programs have costs themselves. So measuring and setting control limits and monitoring control limits has a cost. So when you're talking about next steps and it being viable, you've got to think about, what's my cost of measuring? What's my cost of monitoring? And am I monitoring the right things? And is the action that's translated from that monitoring, let's say my control limit is out of control and I start a project, Are the projects well informed? Can they actually translate into positive ROI or positive process changes? So this is something you could ponder at length, but I kind of wrote it down at the bottom just to give you a sense of how you might want to think about whether there's value to your control limits exercises or your monitoring processes, which is, are the outcomes, which are project work, are those projects actually providing enough benefit to offset the cost of both measuring and monitoring over time? Because if so, then you've got positive value and you've set up your control limits efficiently and you've set up your monitoring program efficiently. But if not, you're almost better just ad hoc reacting to the problems that are formed, because I've seen this a lot in organizations where they invest a lot in measuring, setting up the tools, setting up the systems to measure. They set up a lot of people who are going into the monitoring parts. But if they can't translate that to actual project work based on that data coming in, what's the point of doing all that? Then it's just an additional cost for the organization that also needs to be controlled, essentially. So hopefully that was roundabout a lot of the control limit and next step conversation. I know it's just very introductory, but just as a quick summary to cap off, and then we'll open it up for questions. Control limits, structure monitoring activities to know when processes require attention. That's the real summary. I know we started with more technical upper control limit, lower control limit, but what I'm going to walk away with is at the base of it, that's what a control limit is. It's just helping you understand when an operating process needs support and project support ultimately. Setting control limits requires knowing the scope, the outcomes, or the objectives of the process, as well as the metrics that represent those outcomes. Control limits should be set consciously to enable monitoring for any breakdown in the operating process that requires action. That's the point. And then the next step is structuring projects to remove obstacles to value creation or get the control limits or the process back under control. And just like we finished up just a second ago, control limits and their monitoring should really be considered from an ROI perspective to be sustainable. Don't be the person that sets up all this expensive monitoring and control limit work, and then you can't convert any, because that's not going to help the organization either.
Sam, as always, thank you so much for your time.
Thank you, everyone.